All right, here we go. Talking about adding and subtracting like radicals. This section of these notes, these radical notes, should be fairly familiar for you guys, because adding, subtracting like radicals is really just like adding, subtracting like terms, um, but differences instead of terms, they're radicals, but they work very, very similarly. So let's get a few examples and show you what I mean. Well, first, here's an idea of what like radicals are. So like radical terms are any terms that have the same exact radical in it. So you can see 2 square root of 5 and 4 square root of 5 both have the square root of 5, so therefore they're like radicals. These both have square root of x, so they're like radicals. Square root of 14, square root of 4t, again, all like radicals. They're not like radicals if obviously the radicals are different. So you can really see that kind of be a little more obvious with square root of x and square root of 6x. Very different radicals, so they're not like radicals. Square root of 2, square root of 3. Different radicals, okay? So not like radicals. So like radicals are pretty obvious to identify. They're just like terms. They have the same exact radical. So when I say adding like radicals is the same as adding like terms, I'm not really joking about that. So here you could see us adding like radicals. 2 square root of 5 plus 4 square root of 5. Both terms are square root of 5, so you can add them together, right? 2 square root of 5 and 4 square root of 5 makes 6 square root of 5 because 2 plus 4 is 6. That's exactly the same as if it were 2x plus 4x. It would have still equaled 6x. So they're very, very, very similar. It'll look a little new to us having these square roots, these radicals, but they're treated just the same. All right, so this first example, 9 square root of 3 minus 4 square root of 3. Let's first identify that these two terms are like radical terms because they both have square root of 3 in them. So since they're both like radical terms, we'll just simply combine them together. So 9 minus 4 is 5. So that would make this 5 square root of 3 for A. Now for part B, notice the 6 square root of x and 8 square root of y. The radicals are different. They are not the same. So you cannot combine these terms together. You're not going to be able to make like 14 square root of xy. It won't work that way. For us to be able to add or subtract, emphasis on add or subtract, they have to be like radicals. So yeah, you can kind of see them making note of that there. All right, so here in C, we have square root of m minus 7 square root of m. Now, both of them have square root of m. Square root of m, square root of m. They are like radicals. But what you need to remember here is just like if you saw x minus 7x, you'd have to remember that that's the same as 1x. So in this case, it's the same as 1 square root of m. So when you subtract these like radicals, 1 minus 7 is negative 6. So it would have negative 6 square root of m. For part D, there are 3 terms, but only 2 terms are like radical terms. This third one and this first one. They're both square root of xy. The middle term is not a comparable radical because it's just the square root of y. That radical is different than the square root of xy. So it won't combine with anything, but these two will combine. So I've got 2 and I've got 9. So when I combine them together, I get 11. So together that'd be 11 square root of xy. And then I would just simply bring this other one down, plus 2 square root of y, to be my final answer. Yep. So let's talk about this, though. This is where it gets more realistic for us. Realistic in the sense that these problems aren't always going to be as simple as those first examples were. So here you easily identify the fact that square root of 5 and square root of 20 are not like radicals. So as they sit, you can't combine them. But what you might notice is that neither of these radicals are simplified. So remember in our last video, we talked about simplifying radicals. And remember, if you want to recall, go back to that if you forgot. To simplify radicals, we're looking for these numbers to be divisible by any perfect square. So perfect square is 4, 9, 16, 25, 36, etc. So let's look at 45 first and think what perfect square, which one of these numbers is 45 going to be divisible by? And the biggest one that 45 will be divided by is 9. So 9 times 5 makes 45. So we'll break up the square root of 45 into being the square root of 9 times 5. So the square root of 20, let's look at that as well. The square root of 20, let me fix this radical first. The square root of 20 is not a perfect square. Obviously none of these would work. The biggest number that goes in 20 is 4. The biggest perfect square, that is, that goes in 20 is 4. So 4 times 5 makes 20. So let's go ahead and write that out as well. So now remember, we break these numbers apart. Square root of 9 and square root of 5. Same thing with the square root of 4 and square root of 5. And we simplify each part. So square root of 9, perfect square, is 3. Square root of 5, unlucky, stays at square root of 5. Square root of 4 simplifies, that's a perfect square. Square root of 4 is 2. Square root of 5, again, not so lucky. So we've simplified our radicals, and now you'll notice both terms have like radicals in it. Both have square root of 5. So that means we can combine them. 3 square root of 5 minus 2 square root of 5 to be 1 square root of 5, or simply just square root of 5. So you have to make sure you can really simplify radicals. So go back, rewatch the last video if you're still struggling with simplifying radicals. But in a sense, what you're trying to do is when you're taking the square root of a number that's not a perfect square, you've got to go to your list of perfect squares and figure out which one of those numbers divides into the number inside your radical. Once you figure that out, it's pretty much kind of a piece of cake from there. You just start writing them down, square rooting the perfect squares, and then that second number usually just kind of stays the same, like the square root of 5 here. All right. So here, a very complicated looking one, but it's really just, think of this, there are 3 terms, but think of it as just 3 problems in one, like 3 simplifying problems in one. Let's just simplify each of these one at a time, and then we'll see what we can do after that. So maybe to write this out on the sides, try to make it a little less messy. Let's focus on the square root of 75y first. So the first thing I want to do is separate the 75 and the y. Square root of 75 and the square root of y. No point in keeping them together. And now let's start simplifying the square root of 75. 75 is not a perfect square. But remember, I really hope that by now you've written these down off to the side somewhere because we reference them a lot. Think about which one of the perfect squares will divide into 75. And the biggest perfect square, the only perfect square I think that divides into 75 is 25. So square root of 75 is the same as 25 times 3. 25 times 3 is 75. Square root of y is all by itself. It's not really going to simplify, so we're going to just kind of keep that square root of y just as a square root of y. Square root of 25 and square root of 3 and the square root of y. Just breaking the 25 and 3 up into their own radicals. Square root of 25 is 5. It's a perfect square. That's nice, convenient for us. And square root of 3 doesn't simplify. Square root of y doesn't simplify. So we'll just leave both of them underneath the radical. You don't have to keep them in their own individual radicals. It's a little bit cleaner if we can just put them both under the same radical. So that is square root of 75y. Let me go ahead and write that over here. 5 square root of 3y. So now I'm going to erase this, and I'm going to, I'm going to do the second part of that. So negative 2 square root of 27y. So negative 2, we'll worry about that at the end. We'll multiply that together at the end. But the square root of 27, square root of y, we'll go ahead and start simplifying all this. All right. Go away. All right. Square root of 27. Square root of 27, which of these perfect squares will go into 27? 9 goes into 27, right? 9 times 3. So negative 2, let's keep that there for now. Square root of 9, square root of 3, square root of y. I went ahead and put the 9 and 3 in their own radicals. I knew I would eventually anyway. So square root of 9 is going to become 3. Square root of 3 and square root of y don't simplify, so I'm going to just keep them in the radicals. So now I've got negative 2, and I can multiply that with 3. Since 3 is no longer in a radical, I can multiply it with that negative 2 to create negative 6. So that'll be negative 6, and then the square root of 3y. So let's write that in for the 2 square root of 27y. So it'll be minus 6 square root of 3y. Now let's do the last one, the 48y. So square root of 48y. Let's go ahead and separate the 48 from the y. And let's focus our attention on square root of 48. So 48, it's divisible by 16. That's one of those you might want to memorize. I think for me, I don't know for you, but for me, 16, it's hard to really remember what 16 goes into, because 4 also goes into 16. So sometimes it's divisible by 4, but the bigger number would be 16. So just keep kind of in mind when you see 48, 16 is going to be the one that goes into it. So 48 is 16 times 3. So again, I'm just going to go ahead and put them in their own radicals. Square root of 16, being a perfect square, is 4. Square root of 3 and square root of y, just like the other times, don't simplify. So we'll keep them in their own radical. So let's go ahead and put that in for our square root of 48y. So that'd be 4 square root of 3y. So now all these terms are simplified. Now let's just combine them all together. All 3 of them are like radical terms. All 3 of them have the square root of 3y. So you're just going to combine the 5 minus 6 plus 4. So 5 minus 6 is negative 1. Negative 1 plus 4 would be 3. So I'm pretty sure my answer at the end of this is 3 square root of 3y. So you can kind of see how they simplified it all together. Same thing. Just be careful, kind of like here, when they do the negative 2 times 3. You remember that you can do that. All right, let's just finish this with a geometric application. So find the perimeter of the triangle. Give the answer as a radical expression in simplest form. So remember what perimeter is. Perimeter just means the sum of all the sides. So to find the perimeter of the triangle, you're just going to add all the sides together. 3 squared of 20 plus 10 plus 13 squared of 5. So there's your problem. All we have to do is add these up. Now, again, we're not going to type this in the calculator. The calculator is not going to help us. It'll just give us a decimal, and that's not what we're looking for. So let's just combine like radical terms. Now, given what I've just written down, there are no like radical terms, but we have to make sure each term is simplified first. So I know there's nothing I can do with the 10, but the 3 square root of 20, that square root of 20 can definitely be simplified, right? The square root of 20, let's do it over here real quick. Square root of 20 is not a perfect square, but it is divisible by 4. So So again, here's your perfect squares. You're choosing one of these to go into 20. 4 goes into 20. 4 and 5. So you got square root of 4 times square root of 5, same as square root of 20. So simplify those radicals individually. Square root of 4 simplifies to 2. And square root of 5 is the unlucky one left as square root of 5. So that's your square root of 20. Now keep in mind that we're multiplying that with 3 still. 3 times 2 square root of 5. Plus 10 and then plus 13 square root of 5. Everything's pretty simplified here. Let's just go ahead and multiply the 3 with that 2 to make 6 square root of 5. But this first term and the last term are like radicals. The 6 square root of 5 and the 13 square root of 5 can be combined together. So 6 plus 13 makes 19. So that would be 19 square root of 5. And then the 10 just kind of gets carried down. So there's your answer for this one. So don't be afraid of word problems. Just all you really had to know about this word problem is that perimeter means add up all sides. So you had to know to set it up like this, where you just take each side and add them together, create your problem. Simplify each of these terms. The only one that needed to be simplified was the first one, and then combine your like radicals at the end. All right, so I'll leave you guys to it. The next time next video you'll see is multiplying radicals together. Which, like adding radicals, something I think you guys will be okay with. So we'll see you then.